Question number 22. If A and B are the measures of two equivalent angles, which of the following represents two equivalent angles also, where C belongs to Z? Here we have A and B are two equivalent angles. It is given here. So A equals B plus 2n pi. So with respect to A, add other angle of measure C. What you get? A plus C equals B plus C plus 2n pi. So we have A plus C equals B plus C plus 2n pi. So A plus C and B plus C are two equivalent angles also. Are equivalent. So here we have a right answer in A. With respect to B, subtract C from both sides. So we will get A minus C equals B minus C plus 2n pi. So A minus C and B minus C also are two equivalent angles. So we have a true statement. C here, multiplying both sides in 1 by C. What you get? AC equals BC plus 2nc pi. 2nc pi is a number of full rotations. So AC and BC are another two equivalent angles. So we say are equivalent. So the three statements are true. So we choose all the previous D. And we choose letter D. Question number 23. If the curve y equals x multiply a minus x, which of the following statements is true? First, the curve intersects x-axis at the 2 points 0 and 0, a and 0. So we write y equals x multiply a minus x. In this point, x coordinate equals 0. So substitute here with x coordinate equals 0, we get y equals 0 multiply a minus 0, and the result equals 0. So y coordinate equals 0. Here y coordinate equals 0. So this point is true. Second, we substitute a equals 0 in the equation of the curve. So we get y equals a multiply a minus a. Substituting x equals a. We get a multiply 0. So the result equals 0. So this point also is true. I mean, it is belong to the curve and lies on x-axis. On x-axis, always y equals 0. Y equals 0. Y coordinate equals 0. So this statement is right. It's true. Here, the vertex of the curve is a over 2 and a over 4 square over 4. So again, we have y equals a multiply a minus x. Remember that here, if you have the equation of the curve, quadratic equation, ax square plus bx plus c equals 0, then x coordinate of the vertex, x coordinate of the vertex equals negative b over 2a, negative b over 2a, where b is the coefficient of x and a is the coefficient of x squared. Okay, in this curve we have y equals x multiply a, it is ax. X multiply negative x, it is negative x power 2. Okay, so the coefficient of x squared is negative 1, and the coefficient of x here equals a. So x coordinate of the vertex equals, we have negative b, where b is the coefficient of x. The coefficient of x in this equation equals a. So we write negative a over 2 multiply a, where a is the coefficient of x squared. The coefficient of x squared equals negative 1. So we write 2 multiply negative 1 equals a over 2. So this is the coefficient of, this is x coordinate for the vertex. Now we calculate y coordinate to the vertex. How? Substituting x equals a over 2 in the equation of the curve. In the equation here or here, both are the equation of the curve. The equation of the curve here, y equals x multiply a minus x. So we have y equals x a over 2 multiply a minus a over 2. And we simplify this part, a over 2. Here we have a over 2. Multiply a minus a over 2 equals half a over 2, which equal a over 2. Sorry, equals a over 2, which equal a square over 4. And this is y coordinate of the vertex. So the vertex is the point equals a over 2 and a square over 4. So back to the question here, we have the vertex a over 2 and a square over 2. So this is also a right statement. 3. The axis of symmetry of the curve is x equals a. It is wrong statement. Here this is wrong. Why? Because the equation of the axis of symmetry of the curve is equal to x coordinate of the vertex. So here it must be x equals a over 2. So this is wrong statement, and the two correct statements are in 1 and 2, and we'll choose letter A. Question number 24. In the opposite figure, if the area of triangle ABC equals 72, and we write area of triangle ABC equals 72 centimeter power 2. Then the required here is to find the area of triangle ADB. Triangle ADB here, this triangle ADB. And the given here is AD. Here AD bisects angle A. Bisects angle A. How we use this given? So we write, since AD as a ray bisects angle A, so you can write AC over CD equals AB over BD. That means AC equals 15 over CD equals AB, it's 12 over BD. That means BD here, BD over CD equals 12 over 15, which equal 12 over 15 in the simplest form equals dividing up and down by 3 equals 4 over 5. So we write here the ratio between BD and CD, it is 4 to 5. The two triangles ABD and ABC and have the same height at the point A. If you wanted to draw the height of triangle ABC, it is the same height. Here I'll draw it. It is the same height of triangle ABC. From A, it is perpendicular to the base, right? So this line segment, red line segment here, it is H. Okay, so the ratio between their areas as the ratio between their bases. And here, area of triangle ABD over area of triangle ABC equals 4 over 9. Okay, and also you can deduce that the ratio between the area of triangle ABD and the ACD equals 4 to 5 because their bases on the same straight line and have the same height. So we complete substituting here. Area of ABD, it is the required area of triangle ABD over area of triangle ABC, which equals 72. So it is equal 4 over 9. And here we can calculate it. Area of triangle ABD equals 72 multiply 4 over 9, which equal 32 centimeter power 2. Divide 9 equals 1, divide 9 equals 8, and 8 multiply 4 equals 32, and we choose letter C. Question number 25, cosine theta is greater than 0, so cosine theta equals x, it is positive, and sine theta equals y, it is less than 0, so it is negative. Okay, then theta lies on first quadrant, second quadrant, third quadrant, or fourth quadrant. Okay, let us represent this. We have here x dash and y dash. Remember that x and y are the two coordinates of any point of, or you can say x and y are the coordinates of the any point on the unit circle. And I'll draw here a unit circle like this. So we have here x is positive and y is negative. So this point must lie on the fourth quadrant. Here is x and y. X is positive and y is negative. So the terminal side of theta lies on the fourth quadrant, and then we choose letter D. Question number 26. If L and M are the two roots of the equation, L and M are the two roots of this given equation, x squared minus 5x plus 6 equals 0, then the quadratic equation whose roots are L plus 1 and M plus 1. Here, what is the two roots of this equation? We can factorize it. So it is equal x multiply x minus 2 multiply minus 3. Negative 2 multiply negative 3. So putting x minus 2 equals 0, we get x equals 2. And putting x minus 3 equals 0, we have x equals 3. So the two roots of the given equation, x1 and x2, and you can say that L equals 2 and M equals 3. So the two roots of the required equation here, L plus 1 and M plus 1. So the two roots are, of course, the roots of the required equation are L plus 1. So we have L equal 2. It's 2 plus 1 equals 3. And the M plus 1, 3 plus 1 equals 4. So the required equation will be in the form x minus 3 multiply x minus 4 equals 0. And when you expand this to brackets, what you get? X multiply x equals x squared. X multiply negative 4, negative 4x, negative 3x plus 12 equals 0. So we have x squared minus 7x plus 12 equals 0 is the required equation. Where it is in letter C. And we have another solution for this problem here. We have the given equation is x squared minus 5x plus 6 equals 0. And we know that the sum of the two roots, L plus M, equals negative b over a, equals negative b. And the b here, it is the coefficient of x. It is negative 5 over a equals 1. So the result equals positive 5. So L plus M equals 5, right? And the Lm equals c over a. C, it is the absolute term, which equal 6. Here, it is c over a over 1, which equal 6. And the required equation will be in the form x squared minus the sum of the two roots, plus the product of the two roots equals 0. And from the given, we have the two roots of the required equation are L plus 1 and M plus 1. So the required equation will be in the form x squared minus the sum of the two roots, L plus 1 plus M plus 1. It will be L plus M plus 2 multiply x here, plus the product of the two roots, L plus 1 multiply M plus 1, and it is equal 0. Okay, so we complete. We have x squared minus L plus M. We have L plus M equals 5. So we substitute L plus M equals 5 here. Plus 2 multiply x plus, let us expand this to brackets. So Lm, we have L multiply M, it is Lm, plus L multiply 1, it is L, and 1 multiply M, it is M. 1 multiply 1 equals 1 equals 0. Again, we substitute L plus M equals 5, and Lm equals 6. And we will get here x squared minus 5 plus 2, it is 7x plus Lm. What is the result of Lm? It is 6 plus L plus M. L plus M, it is 5 plus 1 equals 0. So the required equation is x squared minus 7x plus 6 plus 6 here equals 12. So all equals 0. And again, we choose letter C, and we got the same solution. Okay. Next question. Question number 27. In the opposite figure, we have DE is parallel to BC. Where is DE? We have DE here is parallel to BC. Okay. And DC is parallel to BF. Okay. Then the required here is to find AE multiply AF. Okay. So we'll start from the beginning here. And you can say, since CD is parallel to FB, CD is parallel to FB in triangle ABC, what we get? We get this proportion, AD over AB equals AC over AF. AF, okay. This is 1. And concentrate in the other triangle, triangle ADC. No, in triangle ABC here. So in triangle ABC, okay, ABC, we have AD is parallel to CB. So what you deduce? We can deduce that AD over AB, again, AD over AB equals AE over AC. AE over AC. Okay, now we call it 2. And from 1 and 2, we get, let us concentrate in 1 and 2. We have here AD over AB. We have here AD over AB. Okay, AD over AB. and also have here AD over AB. It is the same. So the right hand side here equals right hand side in this proportion here. And we write from 1 and 2, we get AC over AF equals AE over AC. Now cross multiplication. AE multiply AF, AE multiply AF equals AC multiply AC, which equal AC power 2. And we choose letter A. This is the solution. Question number 28. ABC is a right angled triangle at B. So first we draw the triangle here. Draw AD bisects angle A, and we draw AD here to bisect angle A. We have AD bisects angle A. It's the ray. And intersect line segment BC at D. Okay. If the length of BD equals 24, BD, where is BD? BD here equals 24 centimeters, and BA to AC equals 3 to 5. BA to AC equals 3 to 5. Of course, 3, it is not the real length of A. B, also 5. Just it is a ratio between the length of AB and AC. Then the required here is to find the parameter of triangle ABC, which means we wanted to calculate the length of every side in this triangle ABC, because the parameter of any triangle equals the sum of its lengths, of its side lengths. Okay. Now we have, since AD bisects angle A, then we have this ratio AB over BD equals AC over CD. It means AB, it is 3 over BD, it's 24, equals the length of AC, this ratio, it's 5 to CD. And then we calculate CD equals 5 multiply 24 over 3. Divide 3 equals 1, divide 3 equals 8, and 5 multiply 8 equals 40 centimeters. And we write 40 centimeters. Okay, now we want to calculate the length of AB and AC. We have BA to BC, BA to AC equals 3 to 5. It is given. So let BA equals 3x and AC equals 5x centimeters. Now, what is the relation between AB and the BC and the AC? since measure of angle B equals 90, it is given. So applying Pythagoras theorem, we get AB square plus AB plus BC square equals AC power 2, AC squared. So substituting AB equals 3x, we get 3x all power 2 plus BC. What is the length of BC? It's 40 plus 24, it's 64. And we write 64 power 2 equals the AC power 2, it is 5x power 2. That means 5x power 2 minus 3x power 2 equals 64 all power 2. And then complete here calculation. We have 25 x power 2 minus 9 x power 2 equals 64 power 2. 64 power 2 equals 4096. And then we subtract 25 x square minus 9 x square, it is 16 x square equals 4096, and x square equals 4096 divide 16 equals, here divide 16 equals 256. Then x equals positive square root of 256 equals, here we write square root of the answer equals 16. So x equals 16, and now we have AB, then AB equals 3 multiply x, it is 3 multiply 16, which equal 48 centimeters, and the AC equals 5x, right? So 5 multiply 16 equals 80 centimeters. Okay, 5 multiply 16 equals 80. So the parameter of triangle ABC equals AB plus the length of BC plus the length of AC, which equal AB. Here we have AB equals 48 plus BC. What's the length of BC? It's 64 plus AC equals 80. And we calculate this. We have 48 plus 64 plus 80 equals 192 centimeters. So the result here and the answer in letter B. Question number 29. If the ratio between the parameters of two similar polygons is 4 to 9, so we write P1 over P2 equals 4 to 9. Then the ratio between their areas equals one of these ratios. So the required is to find A1 over A2. The ratio between the first area A1 to second area A2. What is the relation between A1 over A2 and the P1 over P2? Here we write A1 over A2 equals P1 over P2 all square. So A1 over A2 equals, this ratio is from the given 4 to 9. So write all square. So it is equal 16 over 81. And the answer will be letter C here. Question number 30. We have XA parallel to straight line, YB parallel to straight line, ZC parallel to LD. Here we have four parallel straight lines. AB equals BC equals CD. Then XY equals YZ equals ZL. So we write, since AB equals line segment BC equals CD, so what you can deduce, we deduce that XY also equals YZ equals ZL. Okay, it is a theorem. We have XZ equals 7 centimeters, and the required is to find the length of XL. So XL also equals, let us calculate it. We have XZ equals 7 centimeters. Then XY equals YZ equals 7 over 2, which equals 3.5 centimeters. Here you can write 3.5 centimeters, 3.5 centimeters, but we have these three parts here are equal. So also ZL equals 3.5 centimeters. So XL equals 3 multiply 3.5, which equal 10.5 centimeters. And we choose letter D. Question number 31. Here we have the solution set of the inequality x multiply x minus 1 is greater than 0, and the required here is to find the solution set of this inequality. First, put x multiply x minus 1 equals 0. Then here it is factorized already, so x equals 0 or x minus 1 equals 0. It means here x equals 1. So this expression equals 0 when x equals 0 or x equals 1. And let us go to number line here and we draw it, this number line, and we divide it here. We have x and f of x. We will study the signs of these two intervals, actually these three intervals. Here we have from negative infinity to infinity. It is the domain of this inequality. It is the domain of this equation here. The domain equals r in r, right? So here put x equals 0, 1, f of x equals 0 when x equals 0, when x equals 1, f of x equals 0 also. And we choose a number lies between negative infinity and 0. A number belonging to this interval, like negative 1, and another number here lies between 0 and 1, like 0.5, and another greater than 1, like 2. And we wanted to check the signs in these three intervals, so we can use calculator. So first write this function x multiply x minus 1 and close the bracket, and we write calc for x equals negative 1. The result equals 2. It is positive, so we write here the sign of f of x is positive, and back to calculator. Calculate for x equals 0.5. It is negative 1 over 4, so the sign here is negative. And the calculate for x equals 2. So we have a positive sign here. Okay. The required here is to find the solution set of this inequality. X multiply x minus 1 greater than 0 means positive. So f of x is positive in two intervals. Okay. Then we write x multiply x minus 1 is greater than 0 when x belong to the interval from negative infinity to 0, open, and the x belong to the open interval from 1 to infinity. So the required solution set of this inequality. So solution set equals negative infinity to 0 union 1 to infinity, which equal r difference from 0 to 1. And we choose letter D. Question number 32. Here we have the minimum value of the function. I write it first. F of theta equals 5 cosine 7 theta. The value of this function depends on cosine 7 theta. And cosine 7 theta here belongs to the interval from negative 1 to 1. which mean cosine 7 theta is minimum when it is negative 1. Cosine 7 theta, it is maximum when it is equal 1. Cosine 7 theta belongs to the interval negative 1 to 1. What does that mean? The minimum value to cosine 7 theta equals negative 1, and the maximum value of cosine 7 theta equals 1. The question here about the minimum value. So we write the minimum value equals 5 multiply negative 1. So it is equal negative 5, because in general the minimum value of cosine any angle equals negative 1. So negative 1 multiplied 5 equals negative 1, and we choose letter C. Question number 33. Here we have sin theta equals negative half, and the tan theta is greater than 0. So we write sin theta equals negative half. That means this angle theta belongs to third quadrant or fourth quadrant. Okay, you know that in the plane here all the trigonometric functions are positive, and here is sine is positive. In third quadrant we have tan, and in the fourth we have cosine is positive. But here we have sin theta is negative. It means the angle, or you can say the terminal side of the angle theta, lies on the third quadrant or fourth quadrant. Okay, and we have from the given tan theta is greater than 0, right? It means it is positive. Tan theta positive in the first here. Tan theta is positive in the first or in the third, right? Third or first. And we write it tan theta is positive when theta belongs to first quadrant or third quadrant. So from this we can deduce that theta lies on the third quadrant. So we write theta, its terminal side belongs to third quadrant. And now let us calculate theta when it lies in the third quadrant. First we calculate theta in the first quadrant. So we write sine minus 1, absolute value of negative half. When you calculate it in your calculator, it is equal 30 degrees. So theta in the first quadrant equals 30 degrees. But theta lies on the third quadrant. So theta in third quadrant equals 30 plus 180, which equal 210 degrees, and you will choose letter C here, letter C, and this is the right solution.